To here. Well, what if it's the case that this thing also takes new data in? Not that much of an extension from what we have here. What we'll do is we'll do the following. We'll say the new x here, and we'll just print this out. That. And instead of doing an a next here, we'll do a bi.ascend. And we'll send a none value in, fine. If we don't want to send that none value in, what we'll have to do is we'll have to do one none up here and then other values here, because it turns out we can't send the non-none value to just our async generator either. And so here, this is the nature of our pumping problem. Our pumping problem is usually to avoid this modality that's happening at the very beginning, because sometimes it can be clumsy to deal with that. Well, here, we can't write an async lambda. Those don't exist. So we can't really do the one-liner version. So we might try and write a pumped, but writing a pumped starts getting quite unpleasant. Because what a pumped needs to do is take an asynchronous coroutine and swap it out with a new asynchronous coroutine. It calls the original asynchronous coroutine and does an await a next on the first entry, and then tries to return this, but this simply won't work. So unfortunately, if we're going to use this approach, we can't actually use the pumping at all. The pumping breaks down in some unpleasant ways. I haven't quite figured out how to pump an asynchronous generator coroutine just yet. But it doesn't mean we have to throw out the approach entirely. It just means that we have to manually handle that modality of, are you at the beginning of the conversation? So let's start with what we had here and see if we're able to do this asynchronously. And what you can kind of see here is whenever we're dealing with these asynchronous structures, it's often the case that we start with something that's synchronous, and then we discover that that synchronous thing needs to invoke the event loop in one way or another, needs to schedule something, so it needs to jump into that event loop. And one async thing makes another async thing, makes another async thing, makes another async, then suddenly your entire program is not an uncommon pattern. But the way we'll do this is as follows. What we can probably do is we can see if we've entered this conversation yet. And if you think about the artificialness of having to send that none value at the beginning, in some cases it's a little bit clumsy, especially as you're composing these things into larger structures. But in this particular case, it's not that clumsy. After all, a conversation does have a first modality. After all, a conversation does have somebody who spoke first. So what we'd have to do is something like this. If message.author, not in conversations. Okay, now we know we have a brand new conversation. We'll say conversations, message.author equals our conversation. Then we'll pump it here. Call this conv. And otherwise, we'll extract our conversation here, and we'll ascend our message into it, and that should work. So that first next will skip this yield. Then we'll immediately pick up with whatever message we've sent there. So if the message is a hello, or while the message is not a hello, we'll just keep getting new messages. And finally, we'll say hello back to you. See if this works. It should be ready to go. Let's nuke our channel just so we can start fresh. And we'll say hello. Okay, very good. Now let's do one more thing. We have to await this as well. So let's try that one more time. Hello. And let's put a couple of print statements in here just so we know what's going on. And let's actually make this a regular dictionary since we are initializing this. And let's see. Oh, and by the way, message doesn't equal hello. There should be message.content. So this is likely the cause of our silence. Let's see if that does it. There we go. And we got our hello back to you. And of course, the thing stopped. So one thing that we might do here is we might say, okay, try. And then when we get an stop async iteration, then we just pass, or maybe we delete this from that. Here, that should be safe to do. So we should now be able to do our simple bot. Hello. Doesn't respond to hello with an exclamation point. Too excitable. Here, it only responds to that. Hello back to you. And now we should be able to get the full breadth of our conversation. Here, it's going to reply hello back to you, and then we'll get another message to come in, and we'll say while message.content, or we'll say if message.content doesn't equal how are you, or we'll say if it does equal how are you, maybe we'll respond something. So we'll get one more, we'll say I am well. I hope you are too. And then, so you can see this is an optional case. And then finally, we'll wait for a goodbye. And what we'll do is we'll say something like backlog equals like this. We'll say while this doesn't equal goodbye, we'll say backlog end message. And then what we'll do is we'll reply goodbye to you. It took you this many messages before you said goodbye. So we should be able to get this working in relatively short order. You can see the generator coroutine approach, when combined with the async approach, does introduce some complexities. These two concepts, well, let's just say there's not a lot of cases in the wild where people are really using these concepts together in this particular fashion, but I actually think that the conversation tree here is quite nicely written, especially from the perspective that we can track any arbitrary state from any part of the conversation to any other part of the conversation. This is way better than modeling these with individual entities. So let's see if this works. We're first supposed to say, the first thing we're supposed to say is hello with no punctuation. Hello, says hello back to you. If we say goodbye, it should say goodbye. Took us 0 messages. Let's try that again. Hello back to you. How are you? Well, I hope you. That's great. I think it's going to be a nice day. Now I know how to write a Discord bot in Python. Bye. And it took us 2 messages. So there we go. We can see a lot of the techniques that we've seen about structuring conversations using advanced features of Python, like generator coroutines and async IO, work fairly well in this Discord.py framework. I would say that in the absence of making use of the Discord.py framework, it's very likely that you're going to create something that looks not altogether too dissimilar from it. I think the callback approach with these on messages, in some cases, is a little bit hokey, but for the most part seems to work fairly well. And without writing a whole lot of code, we can set up some very complex, stateful conversations with our bots, as well as implement our own slash commands, which themselves could be stateful as well, because you can think the same mechanisms that we used here could be used for that slash command. So for example, we might say, if this is your 13th dice roll, maybe if we've been giving you some bad luck so far, just to juice you a little bit, we'll give you some extra good luck, whatever the case may be. I hope that you will join us on our Discord guild or server and share with us some of the ideas that you have for the Discord bots that you want to write. We'd be more than happy to take a look at those and give you any thoughts that we might have on how to make them a little bit easier for you to manage, a little bit more readable, how to deal with some of the weird interactions between these features in Python, asynchronous, as well as the generator coroutines. Whatever the case may be, thank you all for joining us for this session. I hope you have a good starting point for writing your own Discord bot, and I look forward to seeing all of you next time. Thanks, everybody.